Hello, my name is Irene Liu, and this is my final project for the C++ programming class. So in this presentation, I'm going to compare two distinct sorting algorithms, which are bubble sort and insertion sort. Sorting algorithms serve as essential tools for reorganizing a given list of elements based on a specified comparison operator. And this project was inspired by my profound interest in algorithms. So in this first image over here, this is an example of how bubble sort works. And in the second image over here, this is an example of how insertion sort works. During class, I learned about for loops and arrays. A for loop is a control structure that repeats a specific block of code a certain number of times. It's used to automate repetitive tasks, iterate through data structures, and perform computations efficiently. The purpose of a for loop is to reduce the need for writing repetitive code and to make programs more organized. An array is a data structure that allows you to store a collection of elements of the same data type in a block of memory. Arrays provide a way to efficiently manage and access a group of related values under a single variable. Each element in an array is identified by an index. Arrays are widely used for tasks like storing data and implementing algorithms. So here are two examples of code that I used throughout my project. So the first one is bubble sort. Bubble sort is a sorting algorithm that works by repeatedly swapping the elements next to each other if they are in the wrong order. After each iteration, the largest element in the array reaches the end. The pass through the list is repeated until the list is sorted. In the following code, I implemented the bubble sort algorithm to sort an array of integers in ascending order. This algorithm repeatedly steps through the list, compares adjacent items, and swaps them if they are in the wrong order. This process is repeated for each element in the array until the entire array is sorted. In the first line over here, we have a for loop, and it is the outer loop that iterates over each element in the array except for the last one. The variable I represents the current position in the array. In the next line, which has the second for loop, it is the inner loop that iterates over the elements to the right of the current element I in the array. In the next line, we have an if statement. This condition checks if the element at index j is smaller than the element at index I. If this is true, it means the elements are out of order and need to be swapped. Then we temporarily store the value of array I in a variable x, assigning the value, and then we assign the value of array j to array I, and then assign the value of j to x. The two nested loops work together to repeatedly compare adjacent elements and swap them if necessary. As the outer loop progresses, the largest elements bubble up to the end of the array in the correct sorted order. After all iterations are completed, the array is sorted. Insertion sort is the second sorting algorithm, and it works similarly to the way you sort playing cards in your hand. The array is split into a sorted and unsorted part. Values from the unsorted part are picked and placed at the correct position in the sorted part. In the following code, I implemented the insertion sort algorithm to sort an array of integers in ascending order. So in the first line, we have a for loop, which iterates through the array starting from the second element up to the last element. The variable I represents the current position being considered for insertion. In the next line, we store the value of the current element at index I in a temporary variable x. In the line below that, a new variable j is initialized to I minus 1, which points to the last element of the already sorted portion of the array. In the next line, we have a while statement, or we have a while loop. This loop checks if the value at index j, which is in the sorted portion of the array, is greater than x. If so, it shifts the elements to the right to make space for the insertion of x. Inside the loop, array j plus 1, we have array j plus 1 equals array j. So basically this shifts the element at index j one position to the right. Below that we have j minus minus, which decrements j, moving backward through the sorted portion of the array to find the correct position for inserting x. After finding the correct position, we have array j plus 1 equals x, which inserts the value of x into its correct sorted position. The algorithm works by inserting each unsorted element into its appropriate position within the already sorted portion of the array. As the loop progresses, the sorted portion expands, and the array becomes progressively more sorted until all elements are in their correct places. Now I will be demonstrating how this works. So over here, we have our two functions, bubble sort and insertion sort. And then we have an array as an example. So we have nums, and it has 7 integers just in a random order. And so first, we can see how insertion sort works. So we call the function insertion sort, and there's 2 parameters. We put nums since it's the name of the array that we want to sort, and we put 7 since there are 7 integers inside of the array. And we also use a for loop to print out the newly sorted integers in the array. So after we run the file, we can see that now the integers inside nums are sorted in ascending order. Next, we can also try running the program with the bubble sort function. So once again, we call the function and we do the same thing. And after we run the file, we can see that the numbers are now sorted, the integers are now sorted in ascending order as well. So my favorite part about working on this project was learning more about sorting algorithms and implementing the things that I learned throughout this course into the project. If I were to continue to work on this project, I would look into more sorting algorithms, such as selection sort, merge sort, and quick sort. Additionally, I would incorporate time measurements so that I could measure the efficiency of each algorithm. Lastly, I would print out the array after every step, showing the changes in the number arrangement. Thank you.